Good afternoon, everyone. And yeah, will be here presenting the simulating sustainability, what the work I've been doing in DigiEcoQuarry and kind of the work that we have been doing in developing and further advancing our software Plantsmith. And I would like to start by acknowledging the support of the pilot sites, because without their data, we wouldn't be able to do any analysis on the environmental impact. And also, kind of before starting, acknowledging both Adam Sköld at Rock Team and Christina Lee at Chalmers that actually have done the majority of the work. And I'm just taking credit for it now. No. So, I am still working. Okay, perfect. So when we are looking into the environmental aspects of a quarry or a quarry product itself, so there are multiple aspects that we need to take into consideration. One, of course, is the resources that we're using. And now I'm not only referring to the rock material that we are processing, but also all different types of consumable that we're using throughout a given period. This could be the diesel, the electricity, flocculants, AdBlue, everything that's involved in producing those products. And then again, how we set up the process. How is the extraction gone? How is the equipment? How are the machines applied, and the control systems that are actually enabling us to create different products? And on top of that, we have the logistics of how the material is transported, for example, from the blasting until the primary and from the stockpiles to a storage. And what is kind of a key features in our part is this regulation and standards. What framework are we following? So this is a key part here, that we are following a standardized framework that enables us to do the calculations in a structured way, in a harmonious way that is accepted by the industry outside just the quarry industry. So this is where kind of we try to fit our Plantsmith platform in. So it's in a industry-specific EPD platform. So we enable both process simulations and environmental calculations. And what we have tried to do through these 4 years together with DigiEcoQuarry is harmonize it with the current GPI, the program operator instructions, the product category rules, and also the upcoming regulations that are specific for the aggregates. And during those 4 years, everything has changed from when we started. So it's a continuous developing, updating the standards and following kind of what is up to date in order to do those calculations. So quite often when we are talking about environmental impacts, there's a clear focus on the GWP, the global warming potential, or the CO2 equivalent. Usually it's CO2 equivalent per ton, so we're talking specific CO2 emissions. But there's a lot more aspects that quite often needs to be considered to have a global picture, an overall picture of what the environmental impact is for a quarry operation. Some of them might be more important, some of them might be less important, but the key part here is that have a structured framework in order to put them into a context. And as I mentioned, we are following a standardized framework developed by EPD International, and they are the global operator for the EPD framework. There are different subsidiaries of EPD International that might be country-specific, but they are kind of generally following the same rules. And specifically within the Nordic countries, they have a general mutual recognition between the EPDs that are published in Sweden, Denmark, Norway, and Finland. So they have this common agreement. So Plantsmith itself, it's one of the modules that is within the IQS. Sadek mentioned this morning. But the strange thing with the Plantsmith platform is that the user never sees Plantsmith. We are both receiver and producer of information, producer of data. So all the calculations and the estimations are done automatically. That's kind of the beauty of it. But in the back end, what the user doesn't see is the process simulations, equipment and process simulations, and the environmental impact evaluation. So as Plantsmith as a standalone platform, when you start to create your platform, you get this nice canvas to draw your plant in. And it can't be, press the wrong button. Yes. it could be as simple as having just one mobile crusher. So having a single source of material and a single product. But within Digi and in most aggregate quarries, you have multiple products, you have multiple product groups, you have different stages of crushing. You have a primary crusher, you have a secondary crusher, you might have a VSI, you might have want to include more of the drilling and blasting. And a lot of the development in the early phases of Digi was to kind of improve the fidelity of the models that we're actually implementing for each pilot sites. So we added drilling and blasting models, we added comminution devices, classification devices, in order to have the right representation of the product itself. I think Mintek went into a little bit more details into the calibration work that is needed to get the right response. The more work you put into the tuning of the models, the better representation of the site you get. And of course, that comes back to also training, if it's the engineers developing the platform that are doing it, or if it's the operators on site that are doing it. So all depends on the kind of like the user level and the user knowledge of how to set up those models. So running the simulation, you get mass balance, you get energy balance, and cost balance. And few of the results that you get is particle size distribution of different streams that you have in your production line. You get specific energy that we use later on to allocate, for example, the electrical consumption. And in between in the blue boxes here, you get more information of specific stream properties, for example, F80 and P80, how it's entering the sites, kind of a quick indication of the particle size distribution. And when it comes to the environmental part, the general framework is that we need to use 1 year of data. But what we have been doing in the DigiEcoQuarry project is to do it on a periodic basis. Because waiting a whole year to get the environmental data, it loses the significance of actually using that information for proactive decisions. But also, what resolutions are we actually supposed to apply? So what we've gone is to a monthly periodic updates. So we extract the production data, we extract the consumables per month, and then we send back the environmental data. So it's kind of done periodically, month-wise. So what from the data lake, we extract site-specific information that we get. We production through that month, then the consumables had been registered. And then we, based on how we set up the process, we generate an allocation matrix, how to distribute those resources into different product and product groups. And then it's basically generating those results that we have, then those impact factors that are defined by the standards. And then if you're using it standalone, you could generate your UEPG reports or the LCA report, or even a JSON file. And that's basically what we're using and have been developing in the DigiEcoQuarry project to kind of structurize the JSON file that is compatible with the IQS. So all of this is done within seconds automatically within the IQS system. So one of the major development that we have been doing within the DigiEcoQuarry is improving the system structure for the platform, working a lot with cybersecurity, for example. If you are connecting it to a different larger platform as with IQS, it's important that there's no loopholes anywhere, that the system is secured. What is the nice thing with this platform is that we are automatically generating the allocation matrix for the resources in different products. So this is kind of the value adding from the platform. If you're using it standalone, we can generate then this LCA and EPD documentation. Then the producer can then add in their site-specific quarry information to then send to a verification for verification to be published then, publicly, basically. One thing that we haven't been able to explore within the DigiEcoQuarry, but there's still possibilities within the IQS, is to run multiple different what-if scenarios. So that's kind of depending on where your starting point is. And this is kind of a snapshot for the 2024 performance of the different quarries for the CO2 emission per ton. And they are performing quite well, I would say, on a European level. So they are all having quite a nice start point to begin with. And if you would extract, for example, if you're a construction company that you're using these calculations for your own infrastructure projects, and you extract that the same information from Gauti, for example, this is one of the LCA providers, you get a value of 24.8 kilograms per ton. So highlighting the uses of using site-specific information for the downstream process, so kind of improving your numbers further on, actually using the right numbers instead of using generic numbers that don't really mean anything and are not specific for your region. So I say there are multiple scenarios that we can actually run through, kind of fully utilizing the process simulation to simulate sustainability. You could look into change process layout and configuration, change equipment selection, or even change operational strategies. And would like to highlight that these are static simulations, they are not dynamic simulations. So the static simulations, we're not looking into, for example, control systems, improvement of the control systems, how that is affecting the production. So it gives a snapshot of the process, but it usually gives an indicator of the performance if it's getting better or worse at least. We could go any further and we could evaluate the effects of electrification, say that we would go into larger investments in and invest in electrical fleet, for example, changing that diesel consumption into electricity, what impact would that have on our GVP? We might be a producer with multiple quarries in different regions, different countries, so it's easy to change those regions. It's a drop-down menu selecting each country, so you get the right mix. And even if you have a right contract, have a green contract, you can override that data with that kind of mix-specific information. And what is exactly a high topic in Sweden is the effect of biodiesel. How much is that improving your values, changing from regular diesel to biodiesel? And then if you have a cost of equipment, if you want to install a new equipment, how will that affect your cost per ton, basically? Because that's run together with the mass balance and energy balance. We do a cost balance calculation as well. And then kind of specifically for the EPD and LCA framework, it's a contribution analysis and the sensitivity analysis. What is actually affecting what? What resources are affecting your GVP or acidification or eutrophication? So kind of getting a map of what is affecting what. So to kind of give you an overview, so when we do those analysis, we do those calculations, we do it on product group level. So we could get multiple values for each quarry. This is the quarries that we have published EPD in Sweden. The window is not working. So the distribution is all the product groups that are published in Sweden, for example. And within those colored dots, those are the EPDs that we've been published with the tool. And you can see they're kind of usually grouped together closely. But as in this scenario, we had a high level of electrification. This was purely diesel, no electricity applied. So you can see a clear difference, just kind of how what the conditions they have on site. Of course, there are multiple factors, size of the quarry, size of the production, that is also affecting the overall impact. But let's say if we simplify this distribution, smooth it out a little bit, and would look closer into the distribution, you would clearly see that those coarse products, they have a lower impact, intermediate, somewhere around the middle, and the fine products, they will have a higher impact. So you get those trends when you look into the data of the published EPDs that the coarser the products, they've not been processed as much, so they have a lower impact. So it's comparing different quarries, you have to do it with precaution. You cannot have a one-to-one comparison. You need to know what products you're actually looking into and what type of quarry you're actually looking into. So let's say if you're looking at your own specific quarry, you might have a value around 3 kilowatt hours per ton. It was kind of in the lower level of what we had the quarries in the project. And said we want to evaluate process layouts, configuration, deal with optimized control, can maybe improve 10%. We drop a little bit. You go from 3 kilograms per ton CO2 down to 2.8. Okay, that's not enough. I will electrify some of the transport, put in conveyors, move stuff around. So I can, have a huge impact of replacing diesel with electricity. Now, in the remaining of the fleet, I would invest in biodiesel, get additional reduction. And then, based on kind of the setup that I have and the potential that the quarry has, I would see a potential of 40% reduction. Kind of trying to use the tool as kind of make decision of where to find improvements. This is kind of where we see the potential of going forward with the IQS and the Plattsmith platform. So that was kind of a short overview of kind of the simulating sustainability, kind of what capabilities there are, and kind of where we are at the moment, both within the IQS and Plattsmith. So I welcome any question. And you have the QR code to Plattsmith itself if you want to register, and you have my email as well there if you have any direct question.